Download this code from codegive.com, link in the description below. OK, let's dive deep into the evolution from API gateways to sidecar proxies, explaining the concepts, benefits, drawbacks, and providing code examples to illustrate their implementation. This will be a comprehensive guide. The API gateway pattern, a centralized entry point. Concept. At its core, an API gateway is a single point of entry for all external requests to a set of backend services, microservices, legacy systems, etc. It acts as a facade, shielding the underlying services from the outside world and providing a unified and controlled way to access them. Think of it like a receptionist in a large building. Everyone enters through the receptionist, and they direct you to the correct office. Responsibilities. API gateways typically handle these key responsibilities. Request routing. Determining which backend service should handle a given request based on the request path, headers, or other criteria. Authentication and authorization. Verifying the identity of the client and ensuring they have the necessary permissions to access the requested resources. Rate limiting. Controlling the number of requests a client can make within a given time window to prevent abuse and protect backend services. Request transformation. Modifying requests before sending them to the backend, example adding headers, translating data formats. Response transformation. Modifying responses from the backend before sending them to the client, example aggregating data from multiple services, removing sensitive information. Caching. Storing frequently accessed data to reduce the load on backend services and improve response times. Monitoring and logging. Collecting metrics and logs about API traffic to provide visibility into the system's performance and identify potential issues. Protocol translation. Converting between different protocols, example REST to gRPC, HTTP/1.1 to HTTP/2. API composition. Combining the results of multiple backend services into a single response for the client. Benefits. Simplified client experience. Clients only need to interact with a single endpoint, regardless of the number of backend services. Loose coupling. The API gateway decouples clients from the implementation details of the backend services. Backend services can be changed without affecting clients, as long as the API gateway continues to provide the same interface. Centralized security. Authentication, authorization, and rate limiting can be enforced in a single place, making it easier to secure the overall system. Improved performance. Caching, request transformation, and API composition can improve the performance of the system by reducing the load on backend services and minimizing the number of requests that clients need to make. Enhanced monitoring and observability. Centralized logging and monitoring provide a clear view of API usage and performance. Drawbacks. Single point of failure. If the API gateway fails, the entire system becomes unavailable. High availability and redundancy are critical. Potential bottleneck. The API gateway can become a bottleneck if it is not properly designed and scaled. Increased complexity. Developing and maintaining an API gateway can be complex, especially as the number of backend services grows. Ownership and responsibility. Determining which team owns and is responsible for the API gateway can be challenging in large organizations. Examples. Commercial API gateways. APG, Kong, TYK, AWS API Gateway, Azure API Management, Google Cloud API Gateway. Asterisk open source API gateways asterisk Kong, TYK, Ocelot, .NET, Traffic. 2. Sidecar proxies, decentralized service meshes. Asterisk concept asterisk. Instead of a single centralized API gateway, a sidecar proxy is a lightweight proxy deployed alongside each microservice instance. Each microservice instance has its own dedicated proxy running in the same environment, example a container in Kubernetes. The sidecar intercepts all incoming and outgoing traffic for that microservice. It's like having a personal security guard for each microservice, handling the communication security and management aspects. Asterisk responsibilities asterisk. Sidecar proxies typically handle the following. Asterisk service discovery asterisk finding the location of other services in the network. Asterisk traffic management asterisk routing, load balancing, and circuit breaking. Asterisk security asterisk mutual TLS authentication, authorization, and encryption. Asterisk observability asterisk metrics collection, tracing, and logging. Asterisk retries and timeouts asterisk handling transient failures and ensuring reliable communication. Asterisk protocol negotiation asterisk automatically selecting the best protocol for communication between services. Asterisk fault injection asterisk intentionally introducing errors to test the resilience of the system. Asterisk benefits asterisk. Asterisk decentralized governance asterisk policies are applied consistently across the entire service mesh without a central point of control. Asterisk improved resilience asterisk sidecar proxies can handle failures and retries automatically, making the system more resilient. Asterisk enhanced security asterisk mutual TLS authentication and authorization provide strong security between services. Asterisk simplified development asterisk developers don't need to worry about implementing cross-cutting concerns like service discovery, traffic management, and security in their application code. These are handled by the sidecar. Asterisk language agnostic asterisk the sidecar pattern works with any programming language or framework. Asterisk improved observability asterisk sidecar proxies provide rich metrics, traces, and logs, making it easier to understand the behavior of the system. Asterisk drawbacks asterisk. Asterisk increased resource consumption asterisk each microservice instance requires an additional container for the sidecar proxy, which can increase resource consumption. Asterisk increased complexity asterisk deploying and managing a service mesh can be complex, especially for large-scale systems. Asterisk latency overhead asterisk the sidecar proxy can introduce a small amount of latency to each request. However, modern sidecars are highly optimized. Asterisk operational overhead asterisk managing and upgrading the sidecar proxy infrastructure can add to the operational burden. Asterisk examples asterisk. Asterisk Istio asterisk a popular open source service mesh built on top of Kubernetes. Asterisk Envoy asterisk a high-performance proxy designed for cloud-native applications and used by Istio. Asterisk Linkerd asterisk a lightweight service mesh. Asterisk Console Connect asterisk service mesh functionality integrated into HashiCorp Console. 3. API Gateway versus Sidecar Proxy, a comparison. Feature API Gateway Sidecar Proxy, Service Mesh. Architecture centralized decentralized. Scope north-south traffic, external-internal, east-west traffic, internal-internal. Deployment single instance, S, per service instance. Traffic control routing, rate limiting, transformation routing, load balancing, circuit breaking. Security authentication, authorization mutual TLS, authorization. Observability centralized logging and monitoring distributed tracing, metrics collection. Complexity can be complex to manage, can be complex to deploy and manage. Resource usage relatively low per instance, higher overall, per service instance. 4. Code examples. Let's illustrate the concepts with simplified code examples. Note that these are conceptual and would need adaptation for real-world use with a specific API gateway or service mesh technology. A API gateway example, simplified with Ocelot in .NET. 1. Create a new ASP.NET Core Web API project. 2. Install Ocelot new get package *. 3. Configure Ocelot in program.cs*. 4. Create ocelot.json configuration file *. Routes, defines the routing rules. Downstream path template, the path on the backend service. Downstream scheme, the protocol used to communicate with the backend. Downstream host and ports, the address, ES, of the backend service. Upstream path template, the path exposed to the client. Upstream HTTP method, the HTTP method, S, that this route applies to. Global configuration, global settings for the API gateway. 5. Create simple backend services, product and order APIs. These would be separate ASP.NET Core Web API projects. Product API, running on port 5001. Order API, running on port 5002. Now, when you access http://localhost 5000/products, Ocelot will route the request to http://localhost 5001/API/products. Similarly, http://localhost 5000/orders will route to http://localhost 5002/API/orders. B. Sidecar proxy example, conceptual with Istio. This example illustrates the concept using Istio. We'll focus on configuring traffic routing. This assumes you have a Kubernetes cluster with Istio installed. 1. Deploy microservices * deploy your microservices to your Kubernetes cluster. For simplicity, assume you have two services, Service A and Service B. 2. Create a virtual service, Istio configuration. Virtual service, Istio's traffic management configuration. Hosts, the host names that this virtual service applies to. Gateways, the gateways that this virtual service applies to. Mesh applies it to all sidecar proxies. HTTP.route, defines the routing rules. In this case, all traffic to Service A is routed to Service A itself. This might seem trivial, but it demonstrates the control Istio provides. 3. Create a virtual service for traffic splitting, canary deployment. This configures Istio to send 90% of traffic to the original version, v1, of Service A and 10% to a new version, v2. This allows you to test the new version in production with a limited amount of traffic. The sidecar proxies, configured by Istio, handle the traffic splitting automatically. 4. Apply the virtual service *. C. Key takeaways from the examples ***. API gateway, Ocelot configured in a central location. Focuses on routing, transforming, and securing external traffic. Sidecar proxy, Istio configured via Kubernetes manifests. Sidecars are deployed alongside services. Focuses on managing internal traffic within the service mesh, offering features like traffic splitting, resilience, and observability. V. When to use API gateways versus sidecar proxies, service meshes. API gateway *. Asterisk use when you need a centralized entry point for external clients to access your backend services. Asterisk use when you need to provide a unified API for multiple backend services. Asterisk use when you need to enforce security policies, such as authentication, authorization, and rate limiting, for external clients. Asterisk use when you need to transform requests and responses between clients and backend services. Asterisk use when you need caching to improve performance. Asterisk best suited for managing north-south traffic, external requests. Asterisk suitable when you have a relatively small number of backend services. Asterisk sidecar proxy, service mesh. Asterisk use when you have a large number of microservices and need to manage communication between them. Asterisk use when you need to enforce security policies, such as mutual TLS authentication and authorization, between services. Asterisk use when you need to improve the resilience of your system by handling failures and retries automatically. Asterisk use when you need detailed observability into the behavior of your services. Asterisk use when you want to offload cross-cutting concerns, service discovery, traffic management, security, from your application code. Asterisk best suited for managing east-west traffic, internal service communication. Asterisk ideal for complex microservice architectures. 6. Combining API gateways and service meshes. In many real-world scenarios, you might use both an API gateway and a service mesh. The API gateway can handle the external traffic, north-south, while the service mesh handles the internal traffic, east-west. This gives you the best of both worlds. Asterisk API gateway asterisk secures and manages external access, provides a unified API, and transforms requests/responses for clients. Asterisk service mesh asterisk manages service-to-service communication, enforces security, provides resilience, and offers detailed observability within the cluster. Example scenario asterisk. 1. A client makes a request to api.example.com/products. 2. The request hits the API gateway, example Kong, AWS API gateway. 3. The API gateway authenticates the client, applies rate limiting, and routes the request to the appropriate backend service, example product service in Kubernetes. 4. The product service is part of a service mesh, example Istio. The sidecar proxy intercepts the request. 5. The sidecar proxy handles service discovery to find the correct instance of product service. 6. The sidecar proxy enforces mutual TLS authentication between the services. 7. The product service processes the request and returns a response. 8. The sidecar proxy collects metrics and traces the request. 9. The API gateway transforms the response and sends it back to the client. 7. Advanced considerations. Asterisk choosing the right technology asterisk the best choice of API gateway and service mesh technology depends on your specific needs and the characteristics of your architecture. Consider factors such as asterisk scale, asterisk complexity, asterisk security requirements, asterisk existing infrastructure, asterisk team expertise, asterisk cost, asterisk security asterisk implement robust security measures at both the API gateway and service mesh layers. This includes asterisk authentication and authorization, asterisk mutual TLS, MTLS, asterisk rate limiting, asterisk input validation, asterisk web application firewall, WAF, asterisk observability asterisk implement comprehensive monitoring, logging, and tracing to gain visibility into the behavior of your system. Asterisk use distributed tracing to track requests across multiple services. Asterisk collect metrics from both the API gateway and sidecar proxies. Asterisk use centralized logging to aggregate logs from all services. Asterisk automation. Asterisk automate the deployment and configuration of your API gateway and service mesh infrastructure using tools like Terraform, Ansible, or Kubernetes operators. Asterisk GitOps. Asterisk use a GitOps approach to manage your infrastructure configuration. Store your configuration in Git and use a tool like Argo CD or Flux to automatically apply changes to your cluster. 8. Conclusion. API gateways and sidecar proxies, service meshes, are powerful tools for building and managing modern, distributed applications. Understanding the differences between them, their respective strengths and weaknesses, and how they can be combined is crucial for designing robust, scalable, and secure systems. Choose the right approach or combination of approaches based on your specific needs and context. Remember to prioritize security, observability, and automation for a successful deployment.